Hello intellectuals, I am SK Thakur and you are watching this video in Digital Maths Academy. Today's topic is inverse circular function. Inverse circular function means inverse of trigonometric ratios. We have 6 trigonometric ratios: sine, cosine, tangent, cosecant, secant and cotangent. If we have x equals to sine y, then y equals to sine inverse x. Similarly, if we have x equals to cos y, then y equals to cos inverse x. Likewise, if we have x equals to tan y, then y equals to tan inverse x. So such type of relation, y equals to cos inverse x, y equals to tan inverse x, such type of relations are called inverse of circular function, and we can understand it by an example. That is, if we have here sine 30 degree equals to 1 by 2, then you can write 30 degree equals to sine inverse 1 by 2. So here sine inverse 1 by 2 is an angle, so tan inverse x is an angle, cos inverse x is also an angle, sine inverse x is also an angle. Let x equals to sine y. X equals to sine y defines on the interval y equals to minus pi by 2 comma pi by 2, right? Here y equals to minus pi by 2 and pi by 2, that's the closed interval. It means its value will be minus pi by 2 and pi by 2 also. For example, here if y equals to minus pi by 2, x equals to sine minus pi by 2. Sine minus pi by 2, that's a sine minus 90 degree, and that gives us minus sine 90 degree, that is minus 1. But if we put the value of y as plus pi by 2, then x becomes sine pi by 2, that gives us sine 90 degree, that is 1. So we can say here x belongs to, we can say that minus 1 comma 1, and y belongs to, we can say that here minus pi by 2 comma pi by 2. So here domain is minus 1 comma 1, that's the domain. You know, the values of x is, that's always called the domain, and here is the range. The range is always, that is the value of y. Value of x is domain. Value of x, that is sine y, same, right? X or sine y. So its value lies between minus 1 and 1, right? So its value must be less than 1, right? And equals to 1 also, and should be more than minus 1, and that is equals to minus 1 also. So we can say that the domain lies between minus 1 to 1. The value of x should not be less than minus 1 and should not be more than plus 1. Similarly for the range is, that is y, okay, y, or we can say that sine inverse x also, same thing, you know, that's a range. Y is a range, and sine inverse x is also range. So its value lies between minus pi by 2 to plus pi by 2, right? So its value should be more than minus pi by 2 and less than pi by 2, right? So under this condition, only the inverse of sine is possible, otherwise it's not possible. Domain and range of inverse circular function. First of all, the first number, we have y equals to sine inverse x. Here its value, the domain is minus 1, less than or equals to x, and less than or equals to 1. Here its value is minus pi by 2, less than or equals to y, and that's less than or equals to pi by 2. It means it's the range or the principal value. The another name of range is also called the principal value, that's minus pi by 2 to pi by 2. Number 2, we have here y equals to cos inverse x. Cos inverse x, its range is minus 1, less than or equals to x, and less than or equals to 1, same as sine. And its range is little bit different. Here is 0, less than or equals to y, and less than or equals to pi, right? So its value is more than 0 or less than pi. We can say that that's the range. Number 3, here is tan inverse. Y equals to tan inverse x, and its range is here minus infinity, less than x, and there is a less than plus infinitive, right? That's the sign of infinitive. It's sign of infinitive, right? And its range is minus y by 2, less than y, and less than pi by 2, right? That's the range. So we should not have to forget, here is not equals to, it's a less than pi by 2 and greater than minus pi by 2. Number 4, we have y equals to cot inverse x, right? We can take any one here, one by one. I'm going to write all. So for the cot inverse x, we can here minus infinitive, right? And less than, that's infinitive sign, okay? Less than x and less than plus infinitive, right? Same as cot. And here is 0, that is should be less than y, and this is less than pi by 2, right? Number 5 is we have y equals to sec inverse x, right? So its range is here modulus of x. Yes, we can see here modulus of x. That's modulus of x means always positive, and it's more than and 1. Why it's more than? Because the value of, because we know that sec equals to h by b, right? H by b means h is more than b, so its value is always more than x, right? And here we can say that here for the sec, range is 0, less than equals to y, and less than equals to pi, right? And here there is one condition is that now y should not be equal to pi by 2. Why? Because if the value of y becomes pi by 2, then it becomes infinity value, okay? So when there's infinity value, then we cannot do anything, right? So number 6, and the last one is here y equals to cosec inverse x, and for this also the same as sec, because the cosec is also h by p. There is hypotenuse by perpendicular, there's hypotenuse is always more than perpendicular. So here for y equals to cosec inverse x, we can write here modulus of x is always more than 1, right? And here we can write here for the cosec minus pi by 2, less than and equals to y, less than equals to pi by 2. And for this the condition is also y should not be equal to 0. We should not have to forget that the value of y should not be equal to 0. Here graph of sin x and its inverse. So for the graph, we have here x, and then we have the value of y, and y equals to sin inverse x, same thing, right? So for that value, let the value of sin inverse x, that's the value of y is 0 here. Sin 0 is equal to 0, so we can write here 0. Then the value of sin inverse x, yes, we can choose here pi by 4. Pi by 4 means sin 45 degree, and its value is 1 by root 2, and 1 by root 2 means root 2 by 2 also, same thing. Next one is pi by 2, and its value, that's sin 90 degree equals to 1. After that we have here minus pi by 4, right? For the negative minus pi by 4, its value is minus root 2 by 2. And next one is there, we have here minus pi by 2, and its value is here minus 1, right? So we have some values of x and y. Yes, I have chosen, and then we can see that the values of x, that's the values of x equals to minus 1 to 1, right? That's a closed interval. And that of the value of y, that is sin inverse x, its value equals to minus pi by 2 to pi by 2, right? So we can show them in a graph also. So for the graph, we have here x-axis and y-axis. X-axis and y-axis here we can choose. That's the x-axis, and here is y dash, negative and positive y-axis. And then we have here, we have here somewhere there's a pi by 2. Here is pi by 2, here is pi, and here is a minus pi by 2, and over here there is a pi. Upper one there is 1, so here is 1. Down one there is a minus 1. So sin 0 degree is equal to 0. So here it starts from here. Sin starts from here. It goes up maximum at 1, right? Here is 1 pi by 2. It's again falls down and comes to pi, like that it's going on. And down also another side it becomes maximum value, that's -1 here, -1, and then it goes up like that. So this is the graph of, we can say that y equals to sin x, right? And for its inverse, again we can select that here the x-axis and y-axis, right? And for the inverse, the domain and the range are interchanged. So here becomes 1, that side here becomes -1, and upper one somewhere there will be, there is a pi by 2, down one there is a minus pi by 2, right? And it starts from 0 here, so it becomes like this. Okay, it goes up, right? So there is one maximum, sorry, it's a maximum 1 only. Okay, down one there is a maximum -1, right, for this value. So you can say that this is the graph of y equals to sin inverse x. So y is equal to sin x and y is equal to sin inverse x. That's the graph. So for the graph of cos x and its inverse, let's we have some values for x and that of y. That's y equals to cos inverse x. Same thing. So we are going to choose some values. Let here the first value, just we can start cos 90 degree. Yes, we can start from 90 degree also. So we have somewhere there is a pi by 2, right? And it's cos 90 degree is equal to 0. Yes, so it becomes 0. And here we have here pi by 2, pi by 4, 45, and we have here root 2 by 2, and 1 by root 2 is same. Next one is cos 0 degree equals to, we can write here 1. After that, this side we can choose here 3 pi by 4, right, 135 degree, and its value we can say that minus 1 by root 2, or root 2 by 2 also you can write. And last one you can choose here is the pi, right, 180 degree, and its value is -1, isn't it? So we have chosen some values of x and y, right? So we can see here the value of x is from -1 to 1, so we can say that x equals to -1 to 1, right, close bracket. And the value of y, that is cos inverse x, its value equals to, we can say that there's a pi and 0, pi to 0, yes, close bracket, pi also and 0 also. We can show them in a graph also, right? So first of all we can say, we can choose x-axis, here is x-axis, and we have here y-axis, right? And after that somewhere there is a pi by 2, here is a pi by 2, and here is a pi. Here this side we have here minus pi by 2, and we have here minus pi, somewhere there is a minus pi also, and upper one there is a 1 and there is a -1, right? So its value starts from here 1, it comes down, that's 0, 90 degree to 0, okay, and again it falls down, and then again it goes down, goes up like this. Again from here it falls down and it comes to pi by 2, right? It's pi by 2, that's 0, and again it moves like this. Yes, so we can say that this is the graph of y equals to cos x. And for the graph of y equals to cos inverse x, just we can choose x-axis and y-axis, and the domain and the range of course will be exchanged. So this negative x is a positive x-axis, negative y-axis is a positive y-axis, right? So here upper here becomes somewhere pi by 2, down there is a minus pi by 2, right? So and here is 1 and there is a -1, right? So somewhere it starts from here, right? And that it falls like this, it moves like this, and it goes up similarly, right? So this is the graph of, this the graph of, yes, that's not, it's not crossing -1, right? It starts from here. So this is the graph of, there's a y equals to cos inverse x, right? So here I think it's a clear, yes. So -1 to 1, yes, and there is a minus pi by 2, upper one is pi by 2 only, right? So we can say that this is the graph of y is equal to cos x, and it's the graph of y equals to cos inverse x, right? For the graph of tan x and its inverse, let's we have x here, and that of the value of y equals to tan inverse x, same thing. And now we are going to select some values of x and y, that is tan inverse x. So let's we start from 0. So tan 0 degree is equal to 0, yes, we know. Then here is pi by 6 means 30 degree. So its value will be here 10, you know, 1 by root 3. And next one is here pi by 4, 45. So we can write here 1. 10 45 degree equals to 1. Here is minus pi by 6, minus pi by 6, right? We can write here minus 1 by root 3, minus 1 by root 3, right? And minus 1 by root 3 is equal to root 3 by 3 also, same thing. Here also we can write here root 3 by 3, same thing, right? And after that we have here minus pi by 4, and its value is minus 1. We have selected some values, so we can show them in a graph as well, right? So when the graph actually when we show, then we have here x-axis and y-axis, right? So this is negative x, it's a positive x, here is a down negative, up is positive, and then we can see somewhere there is a here somewhere. Now we can say that here we have here pi by 2, and here is we have minus pi by 2, right? So it starts from here because sine tan 0 degree is equal to 0, so it starts from here, and it's trying to go to you know, there's a reach to pi by 2, but it never meeting, okay? So it goes up to infinity. Here it's never meeting, okay? It cannot meet, okay? So again now down also it moves down like this, and it's never meeting this line, okay, here, right? So we can say that here the value of x will be infinity. Here the value of x will be, you know, we can say that minus infinity to infinity, isn't it? Yes, because never meeting, okay? It never meet that line. And for the inverse, we choose here the x-axis and y-axis once again, and in the inverse the domain and range are changed. So upper you can say here is we have pi by 2, and down there is a minus pi by 2, right? And so it starts from here. Yes, we can say that now it starts from here and it goes up like this, okay? It's never meeting, isn't it? Here and down also it goes, and there's never meeting, isn't it? So we can say that, right, it's never ending. So this is your x, and that is the negative x, right? So this is the graph of y equals to tan inverse x, right? So this is the graph of tan and tan inverse x. So we have seen the inverse of sine function is increasing, right? Increasing, and continuous on its domain, and its domain is, we know that there's a 1 comma 1 and close bracket. Yes, so we should not have to forget that. And for the cosine, actually we can say that now it's decreasing, right? It is decreasing, and it's continuous. It's also continuous. So there's a continuous, okay, and continuous, and its domain, actually we know that continuous on domain, and with domain of it is also minus 1 comma 1, that's closed. And here we can say that for the tan inverse of tangent function, here is increasing, right? There is a increasing and continuous. So continuous on its domain, okay. Domain of, we say that there is a minus infinitive, it's infinitive, comma plus infinitive, right? It's continuous now. And after that we see that next one is that here for the inverse of sine function, we say that it's x-intercept, right? It's x-intercept is 0, and y-intercept is also 0. X-intercept means we know that there's a it's not cutting x-axis and y-axis, so we can say that here x-intercept is 0 and y-intercept is 0. But for the inverse of cosine function, it's x-intercept, right? It's a x-intercept, x-intercept equals to, we can say there's 1. Here the sine x-intercept is 0 in the case of inverse of sine function, and in the case of inverse of cosine function x-intercept is 1, right? And here y-intercept, right? We say that y-intercept is pi by 2, isn't it? So we know that here for the for here x, there's a sign, it moves like this, right? It moves like this. So we can say that, there's the x-intercept 0. Sine inverse, sine is never cutting x-axis, but in the case of cos, it starts from here, right? So we can say that its x-intercept is 1, upper one is 1, and the y-intercept is pi by 2, because here is, we saw that there is a pi by 2, right? And in the case of tangent, here x-intercept equals to 0, and here y-intercept is also 0. Y-intercept is also 0. So we know that, there's a tan is moving like this. Okay, so it's never cutting x-axis and never y-axis also. So we know that. Now next one is that here, that it is odd function. It is what now? Odd function. We can say that it is a odd function, right? It is an odd function. So here is a odd function. Odd function means what? Now, odd function means, actually we say that here, if y equals to sine x, right? And if y is equal to sine minus x, so that's sine minus x is equal to minus sine x, right? So this is called the odd function, isn't it? So it's an odd function, and it is symmetric. I am telling that it's a symmetric. Okay, symmetric with respect to the origin. Symmetric with respect to the origin. Why? Because in the case of, now I'm going to show you here, right? So if it is a sine, then you can say that sine is moving like this. Okay, so with respect to origin, right? So left side, right side, you can see the same shape, so it's a symmetric. And in the case of cosine function, we see that it's not symmetric. It's not symmetric, right? It's not symmetric. Yeah, so cosine is not symmetric because left side, right side is not equal, not symmetric with respect to y-axis, okay, and the origin. Yes, it is not, it's not symmetric. Okay, and for the tan, actually for the inverse of tangent function, the graph is symmetric. Yes, the graph is symmetric here. Graph is symmetric, right? With respect to okay, origin with respect to origin, and you can say that any axis with respect to origin, right? And x-axis, right? It's symmetric, and we can say that it is also odd function. How can you say that it's odd function? Because for the tan also, if there's a y is equal to tan x, and there's a y equals to tan minus x, right? Tan minus x, it gives us minus tan x. Okay, so it's we can say that it is odd function. Hope you like this video. If you want to have another part of this video, kindly write in the comment box, like and share this educational channel. If you are new in this channel, then kindly subscribe my channel, because it's your channel. See you in the next video. God bless you. Have a good time.